All right, what's up, class? Let's look at section 8.3. I'm sorry, 8.5. We're going to add and subtract rational expressions. This is section 8.5. Okay, add and subtract rational expressions. Rational means a fraction. Expression means some algebra stuff. So we're going to add and subtract fractions with algebra stuff in them. So let's see what we got here. The first thing I want to talk about is I want to do a brief history of fractions. Let's take a half plus a third. And I can't just add across. You know, says students will want to add, so it'd be 2 over 5. But that certainly doesn't work. The 1/2 and the 1/3 are different sizes. So let's get a little picture here of what these look like. There's a half. And there is a third. And a half plus a third, well, you can't add those together. They're different sizes. So what do? Well, you make them the same size pieces. So 2 and 3 both go into 6, so we divide them both into sixths. And when I divide them both into sixths, now the pieces are the same size. Now they're comparable to each other. So here I have 3 sixths and 2 sixths, and that gives me, 5 sixths. I was about to write 6 over 5. That's crazy. So when we're adding and subtracting any fractions, they have to have a common denominator for this reason. Now we're going to have crazy denominators here. The denominators are going to be like x minus 3 and all kinds of other stuff. But ultimately, the denominators still have to be the same. That's what we're going to talk about in our notes here. Common denominators. Common denominators. Okay, so what do I mean by common denominator? Just something they both go into. So 2 and 3, we've already discussed that their common denominator is 6, because I can divide them into sixths, and then I get the same size pieces. You do the same thing with algebra stuff. 5x minus 1 and x plus 2. Well, just multiply them together. Okay, there's your common denominator. Okay, I don't know what x minus 1 and x plus 2 are. They depend on the value of x. If x is 10, that will be 9 and 12. And they both go into their product if you multiply them together. And I guess that's not the best example because they have some other factor. Anywho, just multiply them together. That'll give you a good common denominator. Let's look at another pair of numbers, 4 and 6. Well, this is a case where you could multiply them and get 24, but that's not the best one. Because 2 goes into both of them, the best common denominator is 12. Now, you could use 24, but it'd be more work. Okay, let's look at an algebra-like example. So if I have x minus 1 and x squared minus 3x plus 2, well, what would that give me? Do they have any factors in common? Well, they do. 4 and 6 have a factor of 2 in common, and I can just see that by looking at the numbers. I know they're both even. I can't really do that here, though, so we need to factor this out manually first. Numbers that multiply to 2 and add to negative 3 are going to be negative 2 and negative 1. And now I can see that these do have a factor that matches. So my common denominator is going to be x minus 1 and x minus 2. This will work for both of these, okay? It's the same as this, and this goes into it as well. There it is right there. So when you have a polynomial like this, factor it to see if we have any matches first. You could just multiply them together to the common denominator, but that would be more complicated than this, and sometimes we have to multiply them out. All right, the next thing is if you have complex fractions. This will be the last thing, just a note here I'm going to share. Complex fractions. Exclamation point. When you have complex fractions or fractions inside fractions, fractions inside fractions, well, what do? You multiply numerator and denominator by the common denominator. Multiply, this will make you feel like a wizard when you do this. Multiply numerator and denominator by the common denominator. Okay, and we'll see what that means when we actually get our hands dirty and look at one of those. So those are your notes for section 8.5, adding and subtracting rational expressions. Booyah!